Welcome to today's lesson on inverse proportion. So yesterday we looked at direct proportion, where as one value increased, so did the other. Okay, now today we're looking at inverse proportion, and as you already know, inverse in maths means the opposite of something, and that is very much the case here. So we see inverse proportion when we're talking about things where as one number goes up, the other one comes down. Okay, so things that are inverse proportional, a very popular example is when we're looking at a job that is being done, okay? And we'll say if it takes one man 20 days to do a job, how many days will it take two men? Okay, and everybody dives in and they say, well, it takes 40 days, okay? It doesn't. Be careful, okay? This is one of those cases where we tell you in maths to remember your common sense. People always forget it. So if we've got, let's say, number of people, okay, along this way, and number of days up the side, okay, perhaps, okay, so, and let's say we've got 1, 2, 3, 4 along here, and up the side, okay, so we're going to say actually it takes one person 20 days to do the job. Now it's going to take two people half that amount of time, isn't it? Because actually if there's two people working, they're going to do twice as much work. So that one's going to come down here. And again with three people, it's going to be a third. Now that's not a very pleasant number in this case, but it's going to be somewhere around here. And you end up with something that looks a little bit like this, okay, is your graph for inverse proportion. They always take that shape, even without all of the other numbers and things on there. Inverse proportion looks like that. That's your general idea of the graph, okay? It might be worth even getting a sketch of that down as an inverse proportion graph. That is what they look like, regardless of what's going on with them. Now, I've got some examples here just to show you how it works in real terms, because of course it's all very well knowing this, but we still have to apply it. So, 3 pipes take 60 minutes to water a field. How long will it take 6 pipes? Now, these kind of questions are very much common sense related, okay? Please don't try and rely too heavily on the maths without checking it makes sense at the end. And I really like to approach these inverse proportion questions with the equal sign in the middle. So I'm going to put 3 pipes equals 60 minutes. Okay, and now we're going to come to something here that is a little bit different, because so far it looks very similar to what we've done in direct proportion. It does differ, okay, so just make sure you're paying attention. Now, I want to know what it's going to take for 6 pipes. I could have done this in a unitary method. I could have gone back down to 1 and then up to 6, but hopefully you can spot that actually I can get from 3 to 6 by doubling it. Okay, so I'm going to times by 2 to get to 6. Now this is where it differs, and I'm going to use a different colour just to highlight this. On the other side, because this is inverse proportion, okay, we're actually going to do the opposite. We're going to do the inverse of times by 2, and we're going to divide by 2 and get 30 minutes. Let's just check, does that make sense? If it takes 3 pipes an hour to water a field, if we have twice as many pipes, it's going to take half as long, isn't it? It makes sense. You could probably do that without the maths, really, if you really sat and thought carefully about it. But it's good practice to learn a new technique on a straightforward question, okay, before you apply it to something more difficult. So there we are. 6 pipes will take 30 minutes. Okay then. So these are very popular exam questions, okay. It takes 5 people 12 days to paint a house. How many people would it take to paint it in 20 days? So again, we've been given an example. 5 people take 12 days. That's what you get to want to highlight or underline. Okay, that's your example. That's all your information there, really. So 5 people equal 12 days. Right then, and we want to know how many it's going to take for 20 days. Now, we want to get to 20 days. There isn't really a very nice way to get from 12 to 20. There's not, is there? There's not a nice way. So we could either divide it and get to 1 day. That's quite a nice way to do it because it's always the same method that way. Alternatively, you could work down to find something that's a factor of 20. So for example, I know that if I divide 12 by 3 I get 4 days, and if I times 4 by 5 I get to 20. Okay, that's another possibility. That's the one I'm going to use for now because it gives us some slightly more pleasant numbers. So if I go down to 3 days, and the reason I've picked 3 days is because I know, sorry, 3, it doesn't go to 20, I meant 4 days, we're going to divide by 3. The reason I picked 4 days is because 4 is a factor of 20, so I know I can multiply from 4 to get to 20. Okay, so I'm going to divide by 3 to get the 4 days. Now, that's a sensible way to do it, okay, if you can see that. However, if you can't spot that straight away, that's okay. Go ahead and divide by 12 and get 1 day. That's fine. Okay, that's absolutely fine. Because then you just need to multiply your 1 day by 20 to get 20, and that's not a problem. Okay. So again, because this is inverse proportion, I'm going to do the inverse of that over here. So instead of dividing by 3, I'm going to multiply by 3. Okay, and 5 multiplied by 3 is 15 people. So it would take 15 people 4 days, okay, to get the paint the house. Take 15 people in 4 days, which is nice. It'd be a bit faster, wouldn't it? Although I do wonder at which point they'd start to trip over each other, really. Depends how big the house is. Okay then, let's now go then from 4 days up to 20 days. So 4 multiplied by 5 gives us 20. And just watch out because we're going to do the inverse of that over here. Okay, we're not multiplying by 5, we're going to divide by 5, the inverse. Divide by 5. 15 divided by 5 is 3 people in 20 days. Okay, now again, I think if you can spot these, it gives you some slightly more pleasant calculations on this side to do. We had some quite nice calculations there, whereas if you'd gone down to 1 you'd have ended up doing 5 multiplied by 12, and that's okay, that's fine. If you've got faith in your mental arithmetic, that's absolutely fine, go ahead and do that. Okay, but that's how we do that one. Now I'm just going to show you one more example and then I'll let you get off. Okay, then a bit trickier this one. A pond takes 135 minutes to fill at 1.2 litres per minute. If it was filled at 5.4 litres per minute, how long would it take? Okay, so we've got a pond and we're saying if it fills up at this speed, 1.2 litres a minute, it's going to take 135 minutes until it's full. That's how long it's going to take. But actually we're then saying, well, what about if we put more water in and it was going in at 5.4 litres a minute, how long will it take then? And that's what we're going to work out. So we're looking in there, we're going to find our kind of information that we've been given, our key information. That's 135 minutes at 1.2 litres a minute. Okay, that's our starting information. 135 mins is at 1.2 litres per minute. Okay, I'm not going to write all that because we can see that's what it is. Okay, litres per minute. Okay, but actually we want to have 5.4 litres a minute. That's what they're saying. 5.4 litres a minute is what we want to know, and then we can calculate out on this side. Now, I can't see any nice connection here, and I can't imagine anybody. There's not a nice connection between them. So I'm going to show you a little bit of a trick here. If you can't see how to multiply this number to get to this number, and that includes, if you can't, I can't even get that down to 1 and multiply back up. There's not a really nice way to do it. There's a little bit of a trick because we want something here. We want to multiply it by something, don't we? Okay. And I'm just going to write down here what we have to do. We're going to do 1.2 multiplied by something equals 5.4. Okay. Now then, remember when we're solving these, okay, I might call my something a variable. I'm going to call it A, just so it's got a letter there. Okay, I'm going to call it A. 1.2 times A is 5.4. Now I want to find out just what A is, so I'm going to solve this for A. Remember to solve, again, we're going to use inverses here, okay, and divide by the 1.2, because at the minute it's A times 1.2. So we're going to undo that and do the inverse and divide by it instead. So we get A equals 5.4 divided by 1.2. Okay, so 5.4 divided by 1.2, which is 4.5. And what we've actually done is worked out what we're timesing it by. Okay, 1.2 times 4.5 is 5.4. So that's a really nice little trick. If you don't know how to get from here to here, you can actually do the number you're wanting to get divided by the starting number, and that tells you what it is you've multiplied it by, okay? So just a useful little thing there. So if we multiplied by 4.5 to get here, on the other side we're going to do the inverse of that, and we are going to divide by 4.5. Okay, and that's going to give us our time. So 135, can we see how we are? 135 divided by 4.5 is 30. Exactly. Well, it's always nice when you get a nice round number. It's reassuring, isn't it? It's 30 minutes exactly. So yeah, you always kind of feel like you've done something right if you get a nice number at the end. So at 5.4 litres a minute, it only takes half an hour to fill up. Okay, so yeah, that's your 3 examples. I would suggest this kind of style of working. And again, the only difference really between inverse proportion and direct proportion in terms of your calculations here is that with inverse proportion you're using the inverse calculation on the other side. Okay, that's the big difference, whereas direct proportion we were doing the same thing on both sides. Okay folks, I'll see you soon. Bye bye.